Hello, friends. Uh, I hope all are safe. There is a very horrifying incident that has been took place in Venezuela, that is situated in the northern part of South America. A doublet earthquake that took place in Venezuela, and the consequences are very severe. As you can see in the image, although this is a AI generated image, but the real incident also similar to this AI generated image. The effect of this doublet earthquake is very severe. Then, what is doublet earthquake? Earthquake means two successive earthquakes that took place with a few seconds or a few minutes. So this is a doublet earthquake. So in this video, as we are dealing with geology, we should know about the regions behind the Venezuela earthquake, and whether geoscientists have already predicted about this earthquake or not. So let's start. So this is an animated video. As you can see, I will play it again. Due to movement of tectonic plates, this earthquake has been took place. So Venezuela has been shocked by has been shaken by two twin earthquakes measuring magnitude 7.2 and 7.5 that struck just 39 to around 40 seconds apart, making them the strongest earthquakes that the country has been experienced in more than a century. Government has declared state of emergency, and according to USGS, the death toll can exceed 10,000, and tsunami warnings has been issued, particularly in areas like La Guaira and northern coastal states of Aragua, Carabobo, and Falcon. So there are two terms, magnitude and intensity. What are these terms? Means, as in the previous slide we have said that magnitude 7.2 and 7.5. So what is magnitude? And another term used very frequently in study of earthquake, that is intensity. So magnitude, as we can compare it with the electric bulb. So how the bulb is brighten, the brightness of the bulb, that is known as magnitude. And suppose you are standing near the bulb, and how much heat you are experiencing, that is known as intensity. That is the difference between, in simple word, this is the difference between magnitude and intensity. Magnitude measures the total amount of energy that released at earthquake source, that is known as focus or hypocenter. It is a single value, and no matter where you are standing on the earth, the magnitude will be same. Suppose you are standing far from the earthquake focus, but the magnitude of earthquake will be same, but intensity will vary. How, I will say later. So how it is measured? It is calculated using using seismographs. Seismographs are graphs that recorded the tremble or the movement of earth. So this is a seismograph is a instrument, so that used to measure the that used to measure the magnitude of the earthquake. And earlier it was the Richter scale, in which the magnitude has been measured, but nowadays another scale, that is movement magnitude scale, has been used. That is, we will not go through what is a movement magnitude scale, but you just remember that movement magnitude scale nowadays used. So what is intensity? Intensity measures the strength of the shaking, and it's the actual effects on people, how structure are there is destruction on the buildings and all, that is measured by the intensity. So it varies by location. Suppose you are standing near to the earthquake focus, so the intensity will be higher. You are standing near the epicenter, so the intensity will be higher. And you are far away from the epicenter, so the intensity will be very lower. So how it is measured? It is measured by observation, that how the engineering assessment, the structural the structural structural infrastructures has been damaged. So how buildings are is there any small crack, is there, the whole building has been collapsed, and is there any small fracture in the road, or any very means very the road has been destructed. So this is the scale of the intensity. So how it is measured? It is measured by Mercalli intensity scale. So and it is um, it is denoted by the Roman scale from 1 to 11. That I, double I, triple I, like that. So this is the two terms that has been used in measuring the earthquake. So now we'll go how what is the region behind Venezuela earthquake. Venezuela sits along the boundary between two plates, that is Caribbean plate, and I am taking the marker, that is Caribbean plate and the South American plate. One of the most tectonic active zone in South America. Caribbean plate moves eastward relative to the South American plate. So the Caribbean plate is moving eastward, so that the rate is roughly 2 centimeter per year, and which is continuously building stress within the earth crust near the Venezuela coast. So northern Venezuela is crisscrossed by several major strike slip faults. Among the most significant are Bocono fault, which runs through the Venezuelan Andes, and the San Sebastian fault, which is a major fault located offshore the Caracas. The Caracas is the place where most destruction has been took place, and this is the most probably the origin of the earthquake. And a pillar fault in this northeastern Venezuela, and Moron fault zone along this central northern coast. So next slide. So this is a animated image. As you can see, this is the San Sebastian fault, and how this is the South American plate, and this is the Caribbean plate, and Caribbean plate is moving 2 centimeter per year, that is 22 millimeter per year, towards the South American plate. So as a result, there are several strike slip faults, and these faults are also connected. We will see in the further slides. So these are some researches that has been took place in 1984. Scovert has been established that basin formation was there along Bocono Moron, a pillar fault system. So according to him, and another called quaternary fault system and stress regime of Venezuela. So this author, Odomed, has mapped the several quaternary faults along the Venezuela, northern Venezuela area, and the concentrated stress, how stress is concentrated along the Venezuela coastal region. So this is the tectonic structure, as I have told. This is the South American plate, this is the Caribbean plate, and this is the Najaga plate. And how this Caribbean plate is moving 1 to 2 centimeter as shown here, and this Najaga plate is also moving 6.5 centimeter per annum. This is the this is also moving eastward. So as a result, this place is a very concentration of a very huge amount of large number of strike slip faults, and there is also concentration of high amount of stress, which release of which has been give rise to this devastating earthquake. So as you can see, total faults has been recognized are 55. So 55 faults has been recognized by this author I have told, the who mapped the quaternary fault. So 55 faults are there, and these faults are also connected. So this is the major region of earthquake in the Venezuela. So, as I have told, these faults are interconnected fractures that accommodate the movement between the two tectonic plates. As stress accumulated over time, the faults eventually rupture, releasing enormous amount of energy in the form of earthquake. For now, experts are focused on aftershocks consequences in Venezuela. USGS forecast indicate a high likelihood of continued seismicity activity of in the coming days. So, another important thing also, earthquake is there is a not there will not be a single earthquake, like a major earthquake will take place and it will finish, but that is not the true case in nature. In nature, several dozens of earthquakes will happen after the major earthquake. So in the first 24 hours after the main earthquake, scientists expect dozen of aftershocks of magnitude 4 or greater. Probability at least one could exceed magnitude 5. So this is the main consequence now. How why this scientist has been worried. The aftershock, there will be dozens of earthquakes. So if such earthquakes will come, so it will take the matter more serious. It will take the consequence will be more devastating. So now hoping for the safe life of the Venezuela people. So I'm ending this video.